Hello everyone. Today let's solve the problem little girl and maximum sum. So this is going to be the last problem in the segment and Fenwick tree playlist. So you can read the entire question here. So I'll just summarize the whole question for you so that it will be easy to understand, right? So let me just give me a second. Let me read the question, right? So we are given an array of n elements and n queries. So we are given an array of n elements and m queries. So what we need to do, each query provides a range of indices. Each query, this one here, each query provides a range. So range of indices. I'll just consider range of for indices I. So here within the range of indices, and we also need to calculate the sum of elements in that range. So we have to calculate the sum of elements in that range. So that's what they have given here. Sum of elements, I'll just write yearly. So the main challenge is to reorder the array and maximize the total sum of all the queries, right? So what is our main goal then? Our main goal is to determine the maximum sum that is possible after optimally reordering the array. So we have to determine the maximum sum that is possible. So we have to determine the maximum sum. Maximum sum that is possible after optimally reordering the array. So what we will be doing here, we have to determine the maximum sum possible after reordering the array, optimally reordering the array. So I'll just keep here reordering the array, right? So this is what the question says. So let's discuss the approach and write the code, or we'll implement the same thing what we will discuss in the approach, and then we will be writing the code. So just give me a second here. So first step is, as usual, we'll be going with the input reading or the input handling. By this time, you have to be knowing the input handling, right? So we'll be going with the Node.js or the JavaScript. This belongs to the input basically. So how we take the input, how we read the input, and how we handle the input, same thing. So this is same for most of the problems, right? So this you'll get to know when we write the code. So the second step, let's discuss the main logic or the core logic. So here, just give me a second here. Just give me a second. So first step is we will parse the input, nothing but we will read the size of the array and number of queries. So this will be input parsing. So first what we will do, we will read the size of the array and the number of queries. So after the first step, let's come to the second step, we'll come to the third step. Nothing but after parsing, after reading the size of the array and the number of queries, we will sort the array. Why we have to sort the array? We have to maximize the sum. Larger element should contribute to the ranges queried more often. So first we will sort the array. So here we will sort. I'll just give sort, or you can just take the sort the array. So after sorting the array, we have to go for the frequency calculation. So for each range query or for each query range, we have to calculate how many times each index of the query is covered. So this can be efficiently done by difference array, nothing but the frequency calculation. So in the fourth step, we will go with the frequency calculation. So this would be the frequency calculation. So when I say frequency calculation, so we, for the each query range, right, we'll be having the particular range. For each query range, we have to calculate how many times each index of the array is covered. So that's what we'll be doing in the frequency calculation. So then we will apply the difference array. So in the previous step, we said that it can be efficiently done using the difference array, right? Nothing but we will be applying the difference array. So to convert the difference array to actual frequencies of how often each element is queried. So this is nothing but the applying the difference array. So after that, let's go with the maximization strategy or the optimization strategy. So let's sort the frequency array again, and we will multiply the highest array values in the most frequent query covered elements to get the maximum sum. First, we will apply the difference array, and then we will sort the frequency array and multiply the highest array values, right? So here, this is nothing but the maximization strategy. So this is nothing but MS. So here we will sort the frequency array and multiply the highest array values with the most frequent query covered elements to get the maximum sum. Finally, after doing this, we will be making use of the Fenwick tree or the binary index tree here, FT or the binary index tree. So why we will be making use of the Fenwick tree or the binary index tree? So for the optimization purpose. So a Fenwick tree or the binary tree, binary index tree will help us manage the frequency to update quickly. Frequency updates quickly, right? So that is the reason we'll be making use of the Fenwick tree or the binary index tree. I hope this is clear. So this is the approach that we will be going with for this particular problem. So after this, we will be getting the output. Then we have to display that output for printing the result, or to output the result, we'll be making use of the console log, and we will be printing the output in the 6th step. So this will be the approach we'll be going with for this particular problem. I hope this is clear. Let's start writing the problem so that you'll understand this one in a better way. So I'll just delete this one. So yeah, let me come here and let's start writing the array. So first step is obviously we will read the input from the stdin. Nothing but we will input array and the query ranges, right? So let's read the input from the stdin. I'll just make use of this one, file stream module. So this will be fs equals require of fs. This is fine. Next, let input equals fs dot read file sync. Will start with 0, and we will set the encoding to UTF-8. So this is one thing. Also, to remove the unnecessary spaces, we'll be making use of the trim, and also to read the input line by line. Let's go with this one. What do you call? Split. I'll just give here /n. So I hope this works. So next, the first line. We have to read the first line. Read n, nothing but the size of the array, and also read q, nothing but the number of queries. So let me consider this one within the destructuring operator. Here, I'll just give n and q. We have to read, so I'll just make use of input. Nothing but this is the first line, right? 0. First line, this one 0 will be within the array. So to distinguish between the different numbers, or we have to segregate the different numbers in the same line, right? So we'll for that one, we'll be leaving the space. I'll be making use of split here. Let's leave the space here, and also we'll be mapping this one of type number. So we'll be making use of the number here to deal with the floating point integers in a good way, right? So you can go for the big int as well. So I'll just be going with the number here. So second line, we have read the first line. Now we have to, second line is nothing but array elements, right? So we have to read we have to consider in this way. So here, I'll just consider in this line itself. This will be let a equals, this will be input of 1. This is because 1, it starts from 0, the line. So second line will be input of 1. And again, to segregate the distinct numbers, we'll be making use of split and leave the space here, and again map, and it will be of type number. So I hope this is clear as well. Next, let's write the queries that follow in the next few lines. So how can we write that? So I'll just take queries here, and let me give input of input dot, this one will be slice of 2 here, map of this one line here, line dot split. Again here, to segregate between the numbers, we'll be making use of we'll be using space within the split. Also, let's map, this will be of type number. This is fine. So next, as usual, we had discussed this one in the approach. We have to sort the array A in the ascending order. Why? Because to later assign values based on the frequency. We will be assigning the values later that is based on the frequency. That is why we need this one array in the ascending order. So I'll just make use of, we have A, right? So I took this one here, this one A, right? Yeah, A dot sort. This is fine. This is correct. This works. Ascending order in the JavaScript we can consider in this way. This will be x minus y. This is fine. After sorting the array A in the ascending order, let's define the Fenwick tree class to manage the range frequency sums. So we have to manage the range frequency sums in a better way, right? So that is the reason we'll be going with the Fenwick tree. Also, now let's define the Fenwick tree class. So let's start here. I'll just give class Fenwick tree here, and let me give constructor. I'll just consider size. Let's initialize the tree with the size plus 1 elements. Also, let's fill initially all the size plus 1 with, let's initialize that one with, let's fill that one with 0. So here for tree, I'll just make use of this. This will be this dot tree here. New array of, we are considering size plus 1, right? So we have considered the parameter size and size plus 1, and we will be filling this one with 0. So I hope this is correct. So next, we'll be using the update method, nothing but we will update the tree at index I by adding the delta to it. So again, I'm telling, we will be updating the tree at index I by adding the delta to it. So we'll be making use of I and delta as the parameters. So this will be update I comma delta here. So while I has to be less than the length of the tree at any cost, right? So that's why I'll be making use of the while loop. This has to be this dot tree dot length here, this dot tree iterated value of the tree, this one equals iterated value of the tree, t of I plus delta. So this is fine. So finally, we will move to the next responsible node, nothing but I equals I plus I and negative I, right? We have to move to the next one. So here I equals I plus I and negative I it will be. So after this, what we have to do, let's carry on with the prefix sum method. Nothing but we will return the prefix sum up to the index I here. So I'll be making use of prefix sum over here. Let me come here and give the name prefix sum. This is nothing but the prefix sum method. So this is the last sum in the playlist. So by this time, if you have followed the previous questions as well, you will be knowing about update, build, prefix sum, how we are calculating the prefix sum. These things you will be already knowing this one. So here we will return the prefix sum up to the index I. So I'll just take the parameter I. I'll just give let sum equals 0 here. I'll just come here. Let's initialize this one to 0. This thing here, while I greater than 0, then what we will do? We will consider this sum equals sum plus iterated value of the tree. Here this will be I. So also we have to move to the parent node in the tree. Previously it was child nodes, right? We were moving to the next responsible node. But here in this step in the prefix sum, we are moving to the parent node in the tree. So here instead of I equals I plus, we will be going with the I equals I minus I and range I and minus I. So here this is fair. And finally, we have to get the sum, right? We have to calculate the prefix sum, and we will get the, we will return the sum. So I hope this is clear. So we are done with the methods and the this one prefix sum update as well as the prefix sum and update. So then next step will be we will create the Fenwick tree to handle the large queries. I can write in this way. So I've already, so I'll consider the variable name Fenwick. I'll just give new Fenwick tree of size n. So this is fine. Let's initialize an array v to store the frequency of each index that is being queried. So here I'll just give v equals new array of size n. Again, we will fill this one with 0 initially. So next, for each query, as we have discussed in the approach, for each query, we have to increase the frequency of the left index and we have to decrease the frequency of the right index. So we are done with the initialization. As usual, we'll be going with next iteration. As I have said, for each query, we will increase the frequency of the left index and decrease after the right index. So let me write in this way. I'll just make use of the for loop. For let I equals 0, I less than q, I plus plus. Let's increment the I. Here within the array destructuring operator. I'll just consider L comma R. Here this has to be queries of I. So here let's increase the frequency at the start of the query range, also decrease the frequency after the end of the query range. That's what we will be doing. For increasing, I'll just make use of L minus 1 equals v of L minus 1 plus 1. We are increasing here. After increasing, what we'll do, if this one R less than n, then we have to decrease. So here it will be v of r equals v of r minus 1. So I hope this is clear now. Then what we will do, we will convert the difference array into the actual frequency counts. So for this one, again, I'll be making use of iteration. Let's start with I equals 1. This has to be I less than n. Let's increment the I. So let's accumulate the frequencies in this step. So here I can write in this way, v of I equals v of I plus previous value is nothing but v of I minus 1. Nothing but we are accumulating the frequencies. After accumulating the frequencies, again, as we had discussed in the approach, we will be sorting the frequency array to maximize the sum. So to maximize the sum here, we have got, right? We have to sort this one in the ascending order. So I'll just give here x minus y. I hope this is clear till here. So this is the last step. Next step, we have to calculate the maximum sum by pairing the highest frequencies within the largest array element. So initially I'll just give sum equals 0. Let's initialize the sum equals 0. This is easy. Next, we have to multiply the array element by its corresponding frequency. Whatever the corresponding frequency we have got, we have to multiply the array element, right, by its corresponding frequency. Nothing but here initially let's this one iterate from I equals 0. This has to be n. Let's increment the I. Finally, what we will do, sum equals sum plus iterated value of the A into iterated value of the V. Nothing but V of I here. So after this one, we will be now here we will be getting the result here in this step, right? So we have to print the result or display the result finally. So for printing or displaying the result, I'll just be making use of the console log, and we have to just print, we have to just keep sum inside. So I hope this works. So let's see with the input. So I'll just copy this one. We have to get the output 25. Let's see. So here we are getting the output 25. So this is working correctly, right? So let's check for the second input. So we have to get the output 33. So let me come here. So yeah, we are getting the output 25 and 33 correctly, right? So we are this code is working correctly. So let me come here. Just give me a second. So I'll just come here. Let me click on submit code. So this is problem C, right? Let me choose the problem C and let me paste the code here and let me hit the submit. So let's wait for some time. So here you can clearly see running on test run, right? Let's wait for some time. So this is taking time. So let's wait for some time. So yeah. So here you can clearly see the code got accepted, right? So you can clearly see here the code got accepted. So this code works absolutely correct. So I had made one mistake, I think, right? Somewhere? No? Didn't I? No. I think, yeah. This was, yeah. The code works absolutely correct. So this is it. Thanks for watching, guys. So one more thing I wanted to tell, this is the last problem of the segment and Fenwick tree playlist. So next I'll be explaining the important algorithms and JavaScript. So I'll just be explaining most of the used algorithms, right? So the important algorithms using the JavaScript, right? So this is it. Thanks for watching, guys.